Hey guys, my name is Akshaya Lakemore and I'm working on the Test 3 exam wrapper, and I'm going to show you guys how to do question number 1, parts A and B. So question number 1 is asking for an object of mass m and velocity v is acted upon by a net force at time t, as indicated in the figure below. And these are the two given figures. And question 1, part A, is asking for, using the numbered direction arrows shown, indicate which arrow best represents the direction of the quantities listed below. If the quantity has zero magnitude, or if more information is needed to determine the direction, indicate using the corresponding number listed below. Alright, so question 1, part A, is asking for 6 different things. The first part is asking for which arrow represents the object's momentum, and we know according to the momentum principle that P equals mv, which is the momentum formula, so that would be this. And in this case, we know that the velocity is given in the upward vertical direction. So mass does not matter in this case. So we know that the object's momentum would equal velocity. So in this case, the answer to number 1 would be the first arrow. The second part is asking for the FNet parallel part, the component of FNet parallel to the object's velocity. So like I said before, we know the velocity arrow is pointing upwards and the FNet is going to the left side downwards. So the F component of that is parallel to the object's velocity would have to be 5 because it is parallel to the velocity vector, and since FNet is pointing down, the parallel vector would also be pointing down. Number 3 is asking for the component that is perpendicular to the object's velocity. It's the same thing here. We know that the FNet parallel is 5, given the thing that we found in part 2. So FNet perpendicular would have to be number 7 in this case, because FNet is pointing towards the left side and velocity is pointing upwards, so we're going to end up getting 7 for the perpendicular component to the velocity. And then number 4, it's asking for the time rate of change of the object's momentum. So for number 4, we know that the net force is equal to dp over dt, which is momentum over time, and we are given that the net force is pointing the leftwards down direction, and in this case that is number 6. So the answer to number 4 would also be the arrow pointing in the same direction as the net force, which is number 6. In number 5, it is asking for the component of dp dt that is parallel to the object's velocity. In this case, in number 2, we had already found the component of the net force parallel to the object's velocity, and when it's relative to time, it would be the exact same directions. In this case, the component of dp dt that is parallel to the object's velocity would also be 5. And with the same idea, in number 6, the component of dp dt that is perpendicular to the object's velocity would still be number 7 according to number 3, because in respect to time, the direction of the perpendicular component does not change. Alright, so question 1, part B, was asking for at time t, the object's speed is A, decreasing, B, increasing, C, it's constant, or D, there wasn't enough information given to determine. So in this case, we know that the FNet parallel is the opposite direction of velocity. So in this case, the object would have to be slowing down, which means at time t, the object speed is decreasing. And to write it down for visual sense, FNet parallel is the opposite direction of the velocity All right, and we can see that here velocity is here, and F parallel we said was pointing downwards because F net is going downwards to the left. So if this is F parallel, the object would have to be slowing down because it is going in a downwards direction.